Hello, good evening everyone. You are welcome back again. So these are what fundamental talking about unit and measurement. We have the fundamental and the derived. But before we go to those aspects, those which are the main aspect of today, we'll be talking about the physical quantities. Now, just take these physical quantities as the head of these two. Now, the physical quantity is divided mainly into two: the fundamental quantity and the derived quantity. Now, fundamental quantities are those quantities that don't depend on any other words, quantities. Now, the three fundamental quantity we have is what? Length, mass, and time. Now, these three, they don't depend, there are still other fundamental quantities, but these are the three main in which others are being what? Derived. There are other fundamental quantities, but these three are the one in which other fundamental quantity are what? Derived. Now, fundamental quantity are those quantity that don't depend on what? The physical quantity, or are not expressed by the what? Physical quantity. Are you getting me? Now, when we talk of derived quantity are those that depend on these three fundamental quantities. Their life depend on what? These three fundamental what? Quantity. Their existence depend on these three fundamental what? Quantity. Let's take example area. Now area with the mathematical formula being length times what? Breadth. Now when we talk about area, when we talk of length and we talk of breadth, we all talk about what? Distance. That means from here to here, you are talking about here. So and when we talk of the distance or measuring, because you still use a ruler to measure the breadth now and the length. So when you measure it, if you still write it in centimeter, in meter, once you are writing in meter and centimeter, we are all talking about length. Do you get? We are talking about length. So the length and breadth are both length. So now we just change the breadth to what? Length, because both of them are what? Length. So we have length times length, which will give us L what? Square. That's the length. Now this form is what we called dimension. Very important to note. Is what we call what? Dimension. What we call dimension. Now we have what we call the SI unit. Now the SI unit. Now we have this as what? Dimension. This is the dimension. This is what? SI unit. Now L in SI unit is what? Meter. That's meter in standard. That's international système international des units. That's in French. Système international des units. That's what we call SI unit. Système international des units, or système international units. Do you understand? So now we have what we called SI units. SI units are the standard units. Those are the units when you solve, you have to write in that standard what? Unit. You are not to write in dimension, you have to write in standard unit. So now we have what we call the M. M is representing length. That's meter. That will tell you 5 meter, 10 meter. When we talk about time, we talk about what? Seconds. Then we talk about what? Mass, which is what? Kg. It will not tell you the boy weighs 5 m. It will not tell you that. It will tell you the boy weighs 5 kg, 5 gram. You understand? But the standard one is what? Kg. That's why when you are solving, they will always tell you to convert your solvings to what? Kg, or from minute to what? Second, because these are the what? Fundamental what? Unit. So now we solve for the area and we get the dimension as what? We get the dimension as what? This is the dimension of area that we solved earlier here. Are you getting me? So now the SI unit is now going to be what? This L will change to what? Meter what? Square. That's that about the first example. Let's go to the second example. First of all, I would love to define the meaning of velocity. Velocity is the change in displacement over what? Time. Is the change in displacement. That's why I underline this. Is very, very important. Very, very important. Is the change in displacement over time. This is very, very important. Now, when we talk about displacement, the reason that makes displacement different from distance is that displacement talk about in a specific direction. They will tell you a boy moves north, they move east. But when they talk of distance, they won't tell you the boy moves north or south or west. They'll just tell you the boy moves 5 kilometers. That is the difference between displacement and what? Distance. So now, the SI unit of velocity, let's solve this now. So the distance and velocity are identified as what? S. Sorry for that mistake. Distance and displacement are identified as what? S. Because they also, you understand, they are identified as what? S when solving. So now, velocity, now let's define this. Velocity is the change in displacement what? Over time. Do you get? The change in displacement over what? Time. This is the simplest definition. So now, when we talk about this distance, we also talk about what? Meter or length. We talk about what? Length. We still talk about what? Length. That is why we have L here. Then we have our time. There's no need to change that. It's already here, time. There's now equals to what? L/T. That's over T. You can write it like this or like this. -1 or minus. Most times it's not advised as per university student, because in secondary school they accept that one, but in university they don't accept you writing this one. They expect you to have understand that LT minus means there is -1 there. So I just write it for those who are not that fast to grab, please. But if you are writing the exam, don't put the 1 as per university student, please. Then SI unit, we have meter per second. Just convert this as I showed you earlier here, up here. So the what? This L is what? L. You convert it to meter. Then this time convert it to what? Seconds. Are you there? So now let's go. SI unit for velocity is this. Okay, so is this, sorry. Okay, so now we talk about acceleration. Now acceleration is the change in velocity over what? Time. Listen very carefully. Is the change in velocity over what? Time. So A is equals to V over what? T. That's the change in velocity over the time. Now we have earlier calculated for what? Velocity. Have you seen? So now what I just do, I use this one to replace what? Our velocity. That's L over T. But in case in exam, you have to, if you can leave small space, solve for the velocity so that the teacher will know what you're doing. Then apply all together with what? Acceleration. That's very good. So here you have L over what? T for the velocity over what? The total T. In your mathematics, they have taught you how to change from what? This to what? Multiplication. From division to multiplication, then we have L times 1, L, then T times T, T what? Square. Are you there? T square. So now we have L, are you there? We have L over T square, that's slash, or you write it like this. Then changing it to SI unit, we have this. So now for force, we say force is mass times what? Acceleration. Is what? Mass times acceleration. So M times L. Okay, the mass, we don't need to touch that one already. It's already in what? It's already a what? Fundamental quantity. So you don't have business with that one. With business we have is what? Acceleration. And we have solved for acceleration to have it this way. You understand? All you just do is what? Impute it, multiply by what? The acceleration. Are you getting me? So now we have what? M times what? L. That's ml over t what? Square equals ml slash t square, or ml t minus 2. That's for dimension Then you now convert it as I showed you earlier using what? This. It's just to help you. That's why I write it like this. This is what length in SI unit is called meter. Time, that is time, then in SI unit is called second. Then mass in SI unit is what's called kg. Are you getting me? So now when you convert it, you have something like this. Most time they don't write this in force. We use the founder of what? Force. That is Isaac Newton. Isaac Newton. You understand? It's Isaac Newton. So we have the last one, Young modulus. Young what? Modulus. So Young modulus is stress over what? Strain. I don't know if this thing was issued there. So this is what? Extension over length times force over what? Area. Now, when we talk about extension, that means something about increase what? Length. And we have length already. So extension means it about increase length. So it's part of what? Length. Extension is still what? Length. And length is still what? Length. So when we convert it to what? Our SI unit, we have mass. This is length. This is length. So when we can change it to SI unit, we have mass, length. That's meter over meter. Are you getting me? We have meter over meter because they are both length. Then from the force, I just pick from here. But when writing for a particular question, explain everything. It attracts mark. So the force, I just picked it from here. That's why I circled it. Replace it with force over what? Area. Our area we calculate what? Meter what? Square. I replace it here. Do you get? Now we cancel. M cancel M. You see, then this square, there's m square, so this square cancel this m inside. It will now remain kg s per second square over m. Now this, now bringing it here, to now become kg over this. So you can go and find out other dimensions, derived quantities that you can find their dimension and SI unit. Just look for mass formulas. They can also give you SI unit. You can also look for formulas in physics like impulse, moment. You can calculate their SI unit. Thank you.